Good afternoon to all. This is a continuation part of the interface protocol part 2, in which we saw the Wishbone interface of the simulation on the VCS and Iverilog that we are going to see in this video. For that, I hope you refer the earlier video for the all the details of the signal. So in this video, we are going to implement the slave part, which connect to the memory, and the signaling like will be the memory read and memory write will be generated with the help of the WE and the select and strobe. Okay, and the memory address will be the from the address itself, and the memory data that going to the memory, it's from the dat I, and the output from the memory is going to the dat O. So, and the acknowledge will be loop back. This we are going to implement in the Verilog code and see how we can simulate on the Iverilog and VCS. The connection look like, and this is from the master side. The slave has the generation of the signals, memory read, write, address, data out and data in. So that will be connected to the dummy memory, we can say, and the connection will be like this. Okay, we are trying our best to have this simulation aspects of this wishbone slave. So we create some signal that emulates the master signals, and slave will be reflected on the memory transaction. We begin with the Iverilog. I hope you gone through my earlier EDA tool for Iverilog. So in that I create one exe file for the graphical user interface, which can we provide the files and get the results. So before going to the simulation, I missed a part. We need to check the wishbone slave, how we write it. We take all the standard signals names as it is. Okay, and these are the memory related signal generations that we seen in the block diagram. So the major part will be like this: memory signals. Memory address comes from the wishbone address itself. Memory data out come itself from the data dat in I actually. And these two signals, apart from these two signals, the memory read is very simple, which is the combinational circuit from the WE. Actually we can skip this part, but this is logically continuation of the what we seen in the. We can directly use this if you need, otherwise this is a standard one. So for the write process, actually there is a CTI, the cycle type indications. So there are 3 or 4 indications are there, like fixed signal, fixed address, then incremental burst, then end of the burst, classic cycles. So from this we create one write signal for the memory. Okay, at the reading side, the data comes at the memory data in from the external memory, and we have to channelize the data, this data, memory data, to dat O. We already seen in this diagram. Okay, memory data I to dat O. So this is implementation of slave, wishbone slave, with the specific width and addresses. These are the standard signals that we are going to refer. We are using these signals for the interface, the memory, apart from the slave. So, and that needs some generation of the read and write signals, and this address data and data in and data out. So acknowledgement generation, this is for the write generation, write signal generation, and this is for the read signal generation. All 3-4 signals connected back to this interface, memory interface signals. Okay, so for the test bench we use the instance of this slave, okay, and some signals, parameters, registers, wires, and one memory is there, okay. So we also use the generation of the clock, reset generation, negative edge clocks for the read or write of memory, so that it will align with the rising edge of the clock. It will see in the waveform itself. We later see that. Iverilog, we need to create a dump file, so we create in initial block, and also we cannot able to visualize the memory contents as so we are at the last time of simulation. We grabs every location and print it on the console, so we will able to view what we are writing, what we are reading, like that. So in initial block we kept the initial signals by default, where wait for the reset and 1 clock. Then we are trying to write using the task. So at location 10 and 12 we are writing ABCD and 1 2 3 4. After 1 clock we are trying to read from the location 10 and 12. The task is very simple. We wait for 1 clock passage, apply the address data, and as we know these are the standard kept to be 1 for the write. Basically W is write, and after 1 clock we release all the signals. So at the last we display some console what address we are writing, what we are writing, okay. Similarly we create one task for the read process. The same write and read is same, only the change is this one, WE. So in read only we are providing the address, and we are getting the data from the date out. To simulate this we need to select two files, these two files, okay. Just compile and simulate. Okay, we back to this. As we know we are writing at 10 and 12 location ABCD 1 2 3, and we are reading from the 10 and 12. It is verified that it is properly writing and reading the memory, and in GTK we are not able to visualize the memory content, so I try to myself to have this printing of this all the memory contents here. So at location 10 we are writing ABCD, at 12 we are writing 1 2 3 4. So in my GTK I am not able to view this while recording this video, so I already get the snap. So the main part is here. So this is a clock, write enable or read. This is a address, 10 is address, 12 is address, then ABCD 1 2 3, that is a data. The memory address is the same that we are seeing in WB address. So memory write operations is there by 2 clocks. So what we are writing, that is data out, ABCD 1 2 3, and while we are reading that at location 10 and 12 with the RD signals we are getting the ABCD and 1 2 3 4. So they summarize that the sample code for this wishbone slave accessing the memory is verified. So we try our best to have that same thing on the VCS. So first of all we need first make file. This is a make file. we are using this file as a list file for our source files, so that we can have that as an input here, okay, with -f arrangement. Okay, seen my earlier videos regarding the EDA tool for VCS, you can get all this make file details. Okay, so we need to also check this .all .txt. in that I just listed what files we are to go for the compilation simulation. So these two files we need. Okay, also we can check the files under the code Wishbone slave. This is the same code that we seen earlier. Okay, so quickly we just review the Testbench file as well. This is the same code we are writing it using for the VCS as well. Okay, so to evoke the VCS, we just, I hope some command is there. Yes, okay, so we need minimum signals from this list. Otherwise, select one of the required signals. I just pause the video and select and pop up the waveform window. So I selected the required signals. I just hit the Ctrl 4. It will pop up the waveform window. Hit F5 the window. In that, little bit rearrange this. Okay, so this is a read, write, memory address, memory data out means data in for the writing, and this will be the required signal, okay, for the reading process. And this is a clock. This is similar as write or read, address, data I, data out. This is memory. In this we can see at location 10 and 12 we are writing ABCD 1 2 3 4. In this way we can have the wishbone simulation based on the sample codes. I hope this video fully for you. Please subscribe my channel and make a comment to some improvement or feedback. Thank you.